Hey class, in today's lesson we're going to talk about solving square root and other radical equations, which is found in section 6-5, part 2 of your book. Our objective is going to be to solve square root and other radical equations. So in example 4, we're checking for extraneous solutions. So it says, what is the solution of the equation the square root of x plus 7 minus 5 equal to x? Alright, so really prior to this section we should have been checking for extraneous solutions. Remember, there are times that when we are simplifying that you may get multiple solutions algebraically. However, when you go back and substitute those values in, they aren't necessarily true. So that would be considered an extraneous solution. So we're going to practice solving these problems. All right, so the first thing we want to do, notice there are two x's here. So what we want to do is isolate the radicals. So we're going to add 5 to both sides. And we'll be left with the square root of x plus 7 equal to x plus 5. Then we need to get rid of the radicals, so we're going to square both sides. And so we'll be left with x plus 7 equal to, and we need to square that, so if you need to throw it in a box, do that. I'll just show you for reference. So it's going to be x squared, 5x, and 25. So that will give us x squared plus 10x plus 25. All right, we'll then subtract x and subtract 7 because originally on the left-hand side we had a linear equation, on the right-hand side we had a quadratic. So this will be gone. And we're going to be left with x squared plus 9x plus 18. All right, if you do AC, that will give us 18. And the factors of 18 that will work here are 3 and 6. Okay, so that'll be 0 equals x plus 3 and x plus 6. Okay, so then in the end, x will either equal -3 or -6. All right, now we need to check to see if there are extraneous solutions. So what we'll do is we'll substitute -3 and -6 back into our problem. So let's do that. So that would be the square root of -3 plus 7 minus 5 equal to -3 if I substitute the first one in. So that will give me the square root of 4 minus 5 equal to -3. That's really 2 minus 5 equal to -3, and that works out correct. So that one, the first one is a solution. All right, let's try the second one. The square root of -6 plus 7 minus 5 equal to -6. That would be the square root of 1 minus 5 equal to -6. And that's really 1 minus 5 equal to -6, which is not true. So this one is our extraneous solution. Okay, the first one is the actual solution. All right, let's try the next one. All right, so again, we want to isolate our variable, our radical. So we're going to subtract 3 on both sides. We're going to be left with the square root of 5x minus 1 equal to x minus 3. If we square both sides, we will be left with 5x minus 1 equal to, and I'm not going to do the box this time, so that would be x squared minus 6x plus 9. Okay, again, we want to move everything that's on the left to the right, so we will subtract 5x and add 1. So that will leave me with x squared minus 11x plus 10. All right, if I do AC, that's going to be 10, so that's 1 and 10, 2 and 5. And the ones that work here are -1 and -10. So 0 would be x minus 1, x minus 10. So that means x equals 1 or 10. All right, so then when I substitute, I'll have the square root of 5 times 1, which is 5, minus 1, plus 3 equal to 1. That would be the square root of 4 plus 3 equal to 1. So that's really 2 plus 3 equal to 1, which is not true. Okay, let's try the second one. 5 times 10 would be 50, minus 1 plus 3 equal to 10. That would be the square root of 49 plus 3 equal to 10, which is 7 plus 3, which does equal 10. So the first one is extraneous, and the second one is the solution. All right, let's keep going. So in example 5, we're solving an equation with two radicals. It says, what is the solution of the equation the square root of 2x plus 1 minus the square root of x equal to 1? All right, here's the deal. In order to undo a square root, we would have to square both sides of the equation. But the only way to do that is to move them on opposite sides. So this square root needs to move. So we will be left with the square root of 2x plus 1 equal to the square root of x and then plus 1. All right, then from here we need to square both sides because we're wanting to deal with the left radical first. So that would leave us with 2x plus 1 on that side, and then on this side I want to do the boxes just so you can see it. This is square root of x and then 1, square root of x and then 1. Square root of x times square root of x is x. This would be square root of x. This one would be square root of x. And this is 1. When you combine these on the diagonal, that would be 2 square root of x. Our answer is x plus 2 square root of x plus 1. All right, again, now I still have a radical on the right-hand side, so I need to move that radical to the other side. So I need to subtract x, or excuse me, move everything away from that radical. So subtract x and subtract 1. So I'd be left with 2 square root of x and then x. Finally, to get rid of this radical, I need to square both sides. So I'll be left with x squared equal to, now this I would split and distribute the power. So 2 squared is 4. Square root of x squared is x. Finally, I need to move everything to one side, so I'm going to subtract 4x on both sides. And you'll be left with x squared minus 4x equal to 0. Now, the greatest common factor here is going to be x. So if I take x out, I'm left with x minus 4. So then x will equal 0 or 4. Now once again, we really should check to see if these are extraneous. So I'm going to substitute in 0. So 2 times 0 is 0, so that would be the square root of 1 minus the square root of 1 equal to 1. Well, that's 1 minus 1, and that does not equal 1. So 0 is extraneous. Okay, the next one, if I put in 4, 2 times 4 is 8, so that'd be the square root of 8 plus 1. Minus the square root of 4 equal to 1. Square root of 8 plus 1 is 9, which we know is 3. Minus the square root of 4 is 2. 3 minus 2 is 1, so this 4 actually is our solution. All right, let's try the last one. Okay, again, we need to move our radical to the other side. So we're going to add the square root of x to both sides. So we're left with the square root of 5x plus 4 equal to the square root of x and then plus 4. Okay, square both sides. We're left with 5x plus 4 equal to, again, I'm going to do the box just so you can see. So it's going to be x, 4 square root of x, 4 square root of x, and then 16. So when you combine on the diagonal, we're going to get x plus 8 square root of x plus 16. Okay, again, we want to isolate the radicals, so we're going to subtract x and subtract 16. So we're left with 8 square root of x on the right-hand side. On the left side, we're going to have 4x minus 12. Okay, finally, again, we're going to square both sides so that we can get the radical to go away. So on the right-hand side, well, let's do the left-hand side first. That's 4x and negative 12, 4x and negative 12. So that's going to be 16x squared, negative 48x, negative 48x, and then this is 144. So this will be 16x squared minus 96x plus 144 equal to, remember here you're going to split and distribute, so that's going to be 8 squared is 64, and then x. Okay, finally I'm going to subtract 64x on both sides. And I'm left with 16x squared. Let's see, that is 9, 15, 160x, negative 160x, plus 144 equal to 0. All right, so from here, we should find their greatest common factor and factor it out. So let's check. All right, so everything can be divided by 16. So 16 is our greatest common factor here. So I'm going to erase. Oh, well, I can't erase anymore. All right, if I take out a 16, I'm left with x squared minus 10x plus 9 equal to 0. Okay, and then when I factor using AC for just this part, AC is 9, so that'd be 1 and 9 are going to work. So this is 16x minus 1 and x minus 9 equal to 0. So 16, if I set this first factor equal to 0, it's not possible. So 16 equal to 0 doesn't exist. So the factor here would be x equals 1, and here would be x equals 9. Okay, then we are going to check for extraneous solutions one more time. So if I substitute in 1, 5 times 1 would be 5, and then 5 plus 4 is 9. So that's the square root of 9 minus the square root of 1 equal to 4. That's really 3 minus 1. It does not equal 4. Okay, so 1 is extraneous. Okay, for 9, 5 times 9 is 45, and 45 plus 4 is 49, so it'd be the square root of 49 minus the square root of 9 equal to 4. So that'd be 7 minus 3 equal to 4, and that one is a solution. So x equals 9 is a solution to this problem. All right, guys, as usual, if you have any questions, please come see me for tutoring.